Hello, my amazing students. This is Mrs. A, and I love math. Today we're working on lesson 64, which is all about domain, and then we're going to talk about the additive property of inequality. Domain is, your domain is where you live. Okay, so where you live is your domain, your area of control. But in this book, what we're talking about when we say domain is what can the variable be? Now, usually when we're talking about domain, we're talking about the variable x, or our input variable, as opposed to the variable y, which is our output variable. We'll learn more about that later. But right now, we're talking about our input variable that we're putting into our equation. That variable has certain values that it is allowed to be, that it can reasonably be, and that would be called the domain. For instance, if we had a problem where we had eggs are 10 cents each and we have 25 cents in our hand, how many eggs can you buy? Well, we don't know how many eggs we need. We're just saying, what is reasonable? How many could we buy? Well, we cannot buy 3 eggs because 3 eggs would be 30 cents and we only have 25. We could buy 2 eggs because that would be 20 cents. We could buy 1 egg because that would be 10 cents. And if we don't need any eggs, we could buy 0 eggs. So we would say that the domain is the set 0, 1, 2. That would be the domain of this problem. What is reasonable for an outcome, okay? Or that we could have the variable be either 0 or 1 or 2, okay? So now we're going to talk about domain for a little bit. If the domain is not specified by the author in the book, then we're assuming the domain is all real numbers. In other words, x could be anything. So here we have x is greater than 2, and we're supposed to graph that given that the domain is real. So we know the real numbers belong on a real number line, and here's 0, and here's 2, and x is greater than 2, so we would put an open circle on x, meaning that 2 cannot be part of the domain, but anything greater than 2 could be part of the domain, and we would go to the right. And that would be graphing x is greater than 2. However, the second one, they have changed the domain. The domain is integers, not real numbers. Now remember, if I'm graphing integers, I would have an integer value at 0, 1, 2, 3, -1, -2, -3, and so forth and so on, right? It would continue on this integer number line. Okay, so that's the domain. Everywhere you see the dots is the domain. So we don't have anything in between here because the domain is just the integers, not the real number line. But it does continue going in both directions, okay? So this is our domain, which means that's what x can be, and they're specifying that x greater than or equal to 3, but then they have a slash through it. So if it's not greater than or equal to 3, then it is less than 3. So we would designate all of the x values less than 3 that are already integers, okay? So here's 3, and 3 is not included in less than 3. So we would say this one, this one, this one, this one, and we would continue going in that direction, but then these would be marked off because they're not in that group. Okay, so here we have a couple more examples. Here we have the domain is real. So that means we're going to be using the whole real number line, and x is greater than or equal to -1. Here's 0, here's -1, greater than or equal to. So we're going to put a closed circle on the -1, but we're going to go to the right because x is greater than or equal to -1. Here we have positive integers. So on our number line, we would have not 0. We would start with 1, 2, 3, 4, 5. Okay, these are the possible values because that's the domain and it would go off in this direction, right? But x is less than -1. Well, -1's over here. -1's not even in the domain. And then we have less than -1. That's certainly not in the domain. So we would say the answer, the solution set, is the null set or the empty set with nothing in it, because there are no numbers in the domain that meet that qualification. All right, so now let's look at another one. Here we have x is greater than or equal to a -5 when my domain is positive integers. Okay, so my domain starts at 1, 2, 3, 4, 5, and it continues in that direction. Those are possible. Then it says x is greater than -5. Well, here's -5 way down here. And none of these are in the domain. But 1 is greater than -5, so that will be where I start. And then every value to the right of that will certainly still be greater than -5. So 1, 2, 3, 4, 5, and on forever. That is the list of counting numbers, isn't it? Our natural numbers or our counting numbers start at 1 and go to positive infinity. So here we're talking about the second part of our lesson, the additive property of equality. And the additive property of equality simply means, in plain English, that I have two sides of the equation equal to each other. I can add the same thing to both sides of the equation, or I can subtract the same thing. Because isn't subtraction just addition of the opposite? So we can use subtraction in the additive property of equality. All right? But here we have a formal definition. If A, B, and C are real numbers such that A is equal to B, then A plus B equals B plus C, and C plus A equals C plus B. Let's break it down a little bit. We know that A equals B, so A equals B already. And aren't they just adding some number C to both sides? It's the same number they're adding to both sides. And here we already know that A is equal to B, and didn't they just add the C in the front of the A and the B? No difference, is it? Okay, so here, now we're talking about the additive property of inequality. The last one was equality. Now it's inequality. And it sounds very much the same. If A, B, and C are real numbers, and A is greater than B, then, oops, I lost my N. Then A plus C equals B is greater than B plus C, and C plus A is greater than C plus B. Let's break it down. We already know that A is greater than B. Here's my A, and here's my B. A is greater than B, and didn't I just add a C to both sides? So adding the same thing to both sides should mean that this side is still greater than this side. Okay, so here we've got A plus C, C plus A. All they did was switch them around. B plus C, C plus B. Switched them around. So here's my A, there's my B. A is still greater than B, and all we did was add the same thing to both sides. So it does not change the inequality at all. Now, how can we use that to solve these three problems? So if we have x plus 2 is less than 0, now we have domain is real. So first let's get this into something a little bit easier. Let's subtract a 2 from both sides. And remember, subtraction is addition of the opposite. So we can use subtraction anytime we want to because it's just adding the opposite of. So it still follows the addition property. Okay, so this is going to cancel and we're going to get x is less than -2. The inequality sign does not change and the domain is real numbers. So if x is less than -2, we have a little number line here. and here is 0, and here is -2. And we're on the real number line, so x is less than -2. Here's a -2. We're going to do an open circle on the -2, and we're going to go off to the less than, off to the left. Okay, and so when you have your x in the front and it's all by itself, look how the less than looks like an arrowhead pointing to the left. Okay, so now we have our domain is the set of integers. So integers, remember, here's 0, 1, 2, 3, 4, -1, -2, -3, -4. Those are the integers. So we're not talking about all that's in between. Okay, so it does go ... and ... doesn't it? So now, how can we get this into a form where we could graph it? If we add a 3 and we add a 3 over here, then what do we have? We're going to cancel that and get x greater than or equal to a -2. Okay, if x is greater than or equal to a -2, then here's a -2. And we're going to go, see the arrowheads moving to the right, and we've got an equal sign. So we're going to make a closed circle showing that the -2 is part of the solution, and we're going to go off to the right. The last one, this is actually one of your practice problems, so I want you to do it on your own. So here, copy it down and then pause your video and go try it on your own and see if you get the answer right. So first of all, we're going to think about what is our domain. Our domain is positive integers. So positive integers, 1, 2, 3, 4, ... Okay, and x is not less than or equal to -2. So wouldn't that mean that x is greater than a -2? So here's a -2 right here. This is 0. This is 1. I mean -1, -2. Now I'm not going to put little sticks on it because that's outside my domain, isn't it? My domain is positive integers, and these are outside. But here's where -2 is. So the open circle is there going to the right, but I'm only going to start my actual values when I hit the positive integers. So that would be the answer to that one. Okay, so, oh, you know what? I see a mistake I did right here. Let's go backwards. That was integer values. So I can't do that because integers don't go in between. Ah, glad I discovered that one. We can only mark the integer values there. Now this one is correct, okay? This one is only positive integers, and so even though this started way over here, we can't actually start graphing them until we get here. So 5 would be included, 6 would be included, and then everything else forever and ever in that direction. These are fun, aren't they? We are almost done with this lesson. These are the last 3 practice problems for you. So the first one, domain is real, so I can't make a mistake on those because reals are easy, right? It's the whole number line. So the domain is anything goes. So now I'm going to graph x is not less than or equal to 4. So here's a 0 and here's a 4. So if it's not less than or equal to, then that would mean it's greater than, isn't it? So we would have an open circle going to the right on that one. Okay, here we have the domain is integers. So you got to help me remember that we're just talking about the big hooks. Nothing in between. Okay, so -1, -2, -3, -4 continues on in both directions, but only the integers. Okay, so x minus 5 is not less than 0. So let's add a 5 to get the x by itself. So we have x is not less than 5 because this goes out. Now, if it's not less than 5, then could we write that as greater than or equal to 5? If it's not less than 5, then it could be 5, and it could be greater than 5. So we're going to graph this, but I'm going to remember to only graph the integers. So here is 5, and guess what? I'm off my chart because 5, 6, 7, 8, 9, it's going to go off in that direction, isn't it? Because it's greater than 5, and I could not graph very many of those. So again, here we have integers. So we're going to, this is my number line, 0, 1, 2, 3. I'll make them a little closer, 4, 5, so I can get a few more on there. You're supposed to pause your video and make sure you're getting this one right. Don't let me do it all for you, okay? So here's the integers. Then we want x by itself, so we'll subtract 2. That's using our addition of a negative number to both sides. And we're going to have 5 minus 2 is 3. So we're going to have x is less than 3. And here's the 3, so we're going to have open circle on the 3. That one's not included. But then nothing in between is included. So the first thing that's included would be this one. So we really don't need to have this one here. Okay? But we would have everything else. And we are done with lesson 64. And I hope that you understand. This is Mrs. A, and may God bless your day.